So let's check this exam problem here. We have this beam as shown in this sketch here, and we want to calculate the flexure design strength per feet kips for this reinforced concrete beam. We have reinforcement of 3 bars of number 10, and we have FC prime equals 4000 psi, F yield equals 60 ksi. The total thickness of the beam or the total depth equals 21 inch, while D equals 18 inches, or the distance between the top of the beam till the mid of the steel reinforcement. So in order to start solving this problem, we will start first by calculating the area steel. We have 3 bars multiplied by 1.27, which is the area of the number 10 bars. You can easily find this table in the reference book, equals 3.81 inches square. So this is the total area of steel AS. After that, we have D as a given, which is 18 inches, because this is the distance between the top of the beam till the mid of the steel reinforcement. So we can just apply in the equation of A equals area steel multiplied by F yield over 0.85 FC prime multiplied by B. We have all of this parameters now. Area steel equals 3.81, F yield equals 60, 0.85 FC prime, which equals 4, because now we are using KSI. So it's either using 60,000 in the top and 4,000 in the bottom, or 60 in the top and 4 in the bottom, multiplied by 14, which is the width of the beam. So A equals 4.8 inch. Now we want the next step, which is to calculate the MN, the nominal moment, which equals area steel multiplied by F yield multiplied by D minus A over 2. We have all of these parameters, so MN equals 3.81 multiplied by 60 multiplied by A over 2, which is 4.8 over 2. All of this divided by 12, because we want to use feet, so we are converting this A, which is per inch, to feet. All of this equals 297 kips feet. You need to take care that this is not the flexure design strength of the beam. This is the nominal strength of the beam, because we can't design based on this value. This is the maximum value that the beam can withstand. But of course we need some kind of factor of safety, and you know that the factor of safety here is called phi. So now we need to calculate phi, because M ultimate will equal this MN multiplied by phi. So what is the phi which we should use? We are going to get this phi using this equation, because we need first to understand or to calculate this parameter, which is ES equals EC multiplied by D minus C over C. Based on this one, based on the epsilon of the steel and the epsilon of the concrete, we will understand which stage this beam in. Is it tension phase, or tension failure, or compression failure, or transient stage? We know that the epsilon of the concrete equals 0.003. We know D, which is 18 inches, but we don't have C. So what does C equal? We know that C equals A over beta. And from where can we get beta? We know that we can get it from this table. It depends on the FC prime. Our FC prime equals 4000 psi, so our beta equals 0.85. So now C equals C equals 4.8, which is our A, divided by 0.85. Based on that, we can see that the epsilon S equals 0.003 multiplied by D, which is 18, minus 4.8 over 0.85 over 4.8 over 0.85, which will equals 0.00666, and this is more than 0.005. So based on this, we will use the phi, which equals 0.9, because this is a tension failure. So now we have phi and we have the nominal strength. So M ultimate equals MN multiplied by phi, which means that M ultimate equals 297 multiplied by 0.9, which equals 267.3 kips feet. So this is the answer, which is the first option, 267 kips feet. There is a very important note here in this problem. You can see that after we reached the value of the M nominal equals 297 kips feet, we actually didn't have to calculate the rest of the problem to find out the answer, because you can see the answers here. They are 267, 297, 319, and 354. You calculated the nominal strength as 297, which is this value here, and we want to calculate the phi, which is going to be multiplied by this value to get the M ultimate. But we know that the phi is less than 1. It's either 0.9 or even a smaller value. So this means that the M ultimate always is smaller than the Mn, and the Mn equals already 297. We have here only one value smaller than 297. So we know that it is not 297 because this is the nominal strength, and there is no way that the design is going to be 319 or 354. So we could actually directly choose this value, which is 267. This is very important, and this is can be very useful for you actually during the exam, and it will save you a lot of time. So that's it for our video today. See you in our next video. Thank you.